just consider a pure salt of a strong acid and a strong base. And as we were considering NaCl, let's just consider NaCl. We have got an NaCl solid. Now what we choose to do is we choose to dissolve it in water. So there is water already. So what is water, by the way? Water is H2O, which is having an equilibrium with H plus and OH minus. H plus and OH minus is very, very less. And you have Kw of water as 10 power minus 14 at 25 degrees Celsius. So let's see, when I just put this NaCl in water, what happens? Water is polar, it is going to rip apart the salt. Any salt it was, what would have become of it? It will give its cation and its anion. Why? Because water is attached. The aqueous means the whole water molecule is attached to Na plus and Cl minus. This is what is going to happen. Now in the solution, what we have, if I see the species in the solution, if I just make the beaker, say this is the beaker, and I'm talking about the NaCl dissolved, the solution of NaCl, then what all things we have? We already had some H plus, some OH minus coming from molecules of water which was having equilibrium with them. So this is, we have whole molecules of water. We have H plus, we have OH minus. H plus means hydronium, by the way. So, and what new species has come? Do we have NaCl? No, we don't have any NaCl, as I have been told to you multiple times in the previous video. But we have this Na plus aqueous. Na plus is also surrounded with water. This H plus is also surrounded with water. So it is H plus aqueous, by the way. And this OH minus is also aqueous. I'm just avoiding to write aqueous. So these are all clinging with water molecule. H plus clinging to water molecule. OH minus clinging to water molecule. Na plus clinging to water molecules. Cl minus clinging to water molecules. So we have Na plus aqueous. So these are the species in the solution. Now the question is, will Na plus react with or join hands with H plus? Obviously not. Or let me take another weird one. Which will Cl minus join hands with OH minus? Obviously not. Why? Because both are minus, right? Both are anions. So negative, negative repel. They are not going to join hands with each other. Let us come to the ones which may happen. Will Na plus combine with OH minus? No, it won't. Will it give this NaOH? No, it won't. You for a split second, even if you assume it gives this, then also NaOH is going to readily break back into Na plus and OH minus. Why? Why? So it is not going to happen. Na plus and OH minus is not going to react and not going to form this. Why? Because NaOH is a strong base. It's a strong base. Even if it is getting formed, if you think it is getting formed, then it is going to readily give back Na plus and OH minus. It doesn't remain, NaOH doesn't remain like NaOH at all. There is no NaOH molecule in water. So you don't have this reaction going on at all. So Na plus and OH minus is not going to react. Okay. Then will Cl minus react with H plus, plus and minus reacts. So will they react? Obviously not. Again, same reason. If they react, they'll form HCl molecule. React means they combine, they join. Then they form HCl molecule. Do we have HCl molecule in a solution? No, we don't have HCl molecule in solution. Why? Because HCl is a strong acid and it readily breaks back. Even if it was there, it will readily break back into H plus and Cl minus. So it is not there. So this also doesn't happen. So what we are seeing is that none of the combination, none of the reactions will happen and these will remain as it is. Will Na plus react with H2O? It is already combined with H2O. Na plus aqueous it is. Okay, so there's no. What I'm asking last is, Na plus, bluff question. H2O, will it do this? Yes, it has already done. Na plus is Na plus aqueous. It is already combined with H2O. So you have H2O attached to Na plus already. You can have chains of H2O attached and we don't care. We just write it as aqueous. This whole solution will remain as it is. So the amount of H plus and OH minus which was there in the solution from this reaction, from the equilibrium of water giving H plus and OH minus, nothing has happened to this. Nobody has reacted with H plus. Nobody has reacted with OH minus. Nobody has reduced or increased these quantities. So the pH of the solution remains what it was, which was 7. So I hope you understand this, that if I take up any strong acid and a strong base combination salt and call it as say Ba, because it was from a strong base which is BOH and a strong acid which is HA, this salt, when it hydrolyzes or reacts with water, the salt on dissolution is going to give you B plus and A minus aqueous, and these two are least interested in attacking the OH minus which is present in water or the H plus which is present in water. They are least interested in attacking and forming BOH or HA. This part doesn't happen. So whatever OH minus was in the solution and H plus was in the solution, they remain as it is, and hence the pH of the solution, if it was at 25 degrees Celsius, then pH remains as 7. So that's it for salt hydrolysis. When the salt is of a strong acid and strong base, I'll just emphasize one point over here. There is no acid-base reaction actually happening. We just call the salt that it must have been created by a reaction of a strong acid and strong base, but we are not actually reacting that strong acid and strong base. We don't have that currently. We just have the salt.